So today we're going to focus on total internal reflection under geometrical optics. So in here we're going to be talking about total internal reflection and how it behaves and how we get it, right? So now we need to also understand that total internal reflection, what does it mean? You need to understand the first term in which is total, right? So, and then you also need to understand the second part in which is internal, and then we need to understand what is the reflection. So, when we talk about total, mainly we just focus on the whole or overall, right? So, when you talk about total, we talk about overall, and then when you talk about internal, remember, internal is what is inside. So when we talk about internal reflection, we talk about the reflection inside, right? So in terms of the overall internal of the reflection. But remember that in geometrical optics, we are dealing with light. So when we deal with light, when we say total internal reflection, we are saying that the whole light is being reflected internally. It was not taken out. So now, when you talk about reflection, we talk about maybe when you are looking at yourself at the mirror. So when you're looking at yourself at the mirror, you see yourself there. So when you see yourself there, that's what you call a reflection. But that is not a total internal reflection. That is just a reflection. Total internal reflection is happening inside the medium, not outside the medium. So the mirrors are not doing total internal reflection, but they're just doing a reflection. So we will also talk about rough surface and the smooth surface when we're going to talk about reflection. But now let's focus on total internal reflection. Total internal reflection. Where do we find them and how do we find them? The laws of total internal reflection is that the incident ray must move or travel from a medium of high refractive index to low refractive index. We mean that in terms of us identifying total internal reflection, these are conditions. These are conditions for total internal reflection. We say that the incident ray or the light must move or travel from the medium of high refractive index to the medium of low refractive index. What we mean is that N1 must be greater than N2. Refractive index of the first medium should be greater than the refractive index of the second medium. So this one might be 10, this one must be 8. If this one is 20, this one must be 10. As long as the first medium is bigger than the second medium, then the total internal reflection can happen. The second condition is that the incident angle must be greater than critical angle. The incident angle must be greater than critical angle. We will talk about what is critical angle and then how do we see critical angles. So we are saying that the incident angle must be greater than critical angle. If your critical angle was to be found as 41,25, meaning that in order for total internal reflection to occur, must be 42 and above, greater than critical angle. So this is the conditions of total internal reflection. And then where and how do we, and where do we find total internal reflection? We find them in the instruments for total internal reflection is what we call optical fiber. This one is an instrument for total internal reflection. These are optical fibers. Optical fibers, they are using we use them for telecommunication. When we need to communicate, we use telecommunication for total internal reflection. We also use them in a medical or medicinal instruments, where if I want to check your what is happening in your lungs or maybe in your stomach, then I just put it in your mouth and then I check, and then the light will tell me exactly what is going on. So most of the things that you immediately you understand them, you will see that optical fibers are the fibers or the cables we use to transport information through light. And then they're very fast. They are very fast. The light that is traveling there is very fast. Why it's fast is because the light is traveling at 3 times 10 to exponent 8 meters per second. So the speed of light in that medium is still 3 times 10 to exponent 8. So now optical fibers is an instrument used for total internal reflection. But the medium that are using optical fibers is for telecommunication and medicinal instruments, where now those things we use them to communicate with each other, or maybe we use them to scan or see parts in somebody's people and all those. So this is total internal reflection. These are the conditions for total internal reflection, and then now we need to show it by a little bit of a diagram. So where we can say that when we have something like this, we can say that this one is just a cable, and then we have another one in here. We have another one in here. So this cable is an optical fiber. So this is optical fiber. Now immediately the light enters into the medium, and then it does what you call total internal reflection. So immediately the light enters here. This one it's the core. This one is the core, and then this one is the pedal. So they are using these materials in order for the total internal reflection to occur. But remember that we are saying that the refractive index for the first medium must be greater than the refractive index of the second medium. It means that this the core has a very high refractive index. Refractive index of number 1 is greater than the refractive index of number 2. So which means the core is having a higher refractive index than the cathode. So immediately if this is the case, then the total internal reflection it will occur. And then remember that every time we have an imaginary line called a normal, so that it can create the bouncing of the light inside. So the light will travel through this core and deliver the information. So this is total internal reflection, and then how we interpret it. So whenever you have questions regarding total internal reflection and the conditions, you come here. When they ask you about the instrument used, you say it's optical fiber, and then we can be able to enjoy this topic.